All right, let's play around with functions for a moment. Domain and range of a function. So this looks like a chunk of a parabola cut off on one side and the other. Solid point indicates we get that point. The open point right here indicates we don't get that point right there. We just get up to the edge of it. Domain are your x values. What x values are allowed here? And if we look at this, we can see the leftmost x value appears to be -1 and the rightmost x value appears to be 3. Because of the solid point here, we get -1. Because of the open point there, we don't get +3. So for the domain, a couple ways I could state that. I could use interval notation, meaning we use square brackets to indicate we can use that number, and a parenthesis to indicate right up to the edge of the other number. And so we start at -1, we go up to 3. Inequality notation, there's a couple of ways to state that. We could just do a three-way one where we say x has to be greater than or equal to -1 and less than 3. So the less than goes to the parenthesis, greater than or equal to goes to the square bracket on the left. So the domain here would be any x values between -1 and 3. Range, those would be the y values. And so it looks like this thing peaks at 4, and I'm going to guess it actually hits 4. And then the lowest y value appears to be -5 down there. So the range of this sucker here appears to be, and we always go smallest to largest, so that would be -5 on one side and 4 on the other. And we don't get -5 because of the open circle. So that's a parenthesis. And then I'm assuming we do hit a peak of 4 there. It's just a guess. So that's what I would say the range of this function is. Or in inequality notation, y has to be greater than or equal to, nope, no equal to, I lied. Y has to be greater than -5 and less than or equal to 4. Let's try another one. Which value of t is not in the domain? So sometimes for a domain, we say, well, what is in there? What x values do we have? And sometimes it's easier to say, well, what's not in there? And in this case, I have a denominator and we can't have 0 in the denominator. So identifying the domain by saying what's not in the domain, here we're using t as the independent variable instead of x. And if the denominator equals 0, I have a problem because division by 0 doesn't lead to an answer. So the denominator can't be 0. So I just solve -2t minus 34 can't be 0. Add 34 to the other side. Divide by -2. And we get t can't be -17. And we could graph that to check. What we should find is there's something weird going on there at -17. Let's try another. Actually, let's graph that sucker to check it out. I think I'll use Desmos today. And give me a sec to bring it up here. I'm going to use f of x notation. Whoa, if I could type. And it is 32 divided by -2x minus 34. Let's take a look at this. And -17 was the one I was concerned about. So I am going to zoom out and see what's going on. And I can see, yeah, look, there's something weird. It rises up on one side, -17 is over here, drops down on the other. If I graph that vertical line, x equals -17, well, I believe what I'll see here is that's an asymptote. So if I scroll up, I can see this thing is striving to get close to it. The closer I pick an x value to -17 on the left, the higher I am on that side. Ooh. And then on the other side, the closer I get to -17 on the right, the further down the function gets, but I can never actually get to -17. Let's try another. So here, which value of t is not in the domain? I would just say t equals -17 would be the way I would answer this one. Oops, my pen is being freaky. Alternatively, if I needed to state the actual domain, there's a few ways to say it. I could say something like all real numbers except -17 in words. If I wanted to use that interval notation, I would just have to skip over -17. So let's do an inequality first. X can be any number, or excuse me, t can be any number less than -17. Or since they're not connected, t could be any number greater than -17. In interval notation, so again, these are two different ways to state what the domain is. Interval notation, to say I want a number less than -17, I would put a parenthesis for -17 on the right side, and then -infinity means go to the left forever. And then sometimes we put a union instead of an or in between. And on the other side, I can't have -17, but I could go to the right forever. So here are three different ways to say the same thing, and these are the numbers we're allowed to plug in. What can the input be? Input can be any number that fits that description. Square root functions are another place things get a little sketchy for domain. And the catch here is that if we try to take the square root of a negative number, we get imaginary numbers, which are not real numbers. And usually we're just concerned about real numbers. And we're looking for x numbers that are real. So I, square root of a negative, is not real. So I just want to make sure the inside is not negative. And the inside is called the radicand. So I want to just make sure the radicand is not negative. So my radicand is 3x plus 8. Not negative means greater than or equal to 0, right? Not negative could be positive, or it could be 0. So greater than or equal to 0. Solving this gets me the domain. So I would subtract 8 over and divide by 3. Oops, not -3, sorry. And dividing by a positive, subtracting a number to the other side is cool. If you multiply or divide by a negative number, you have to flip the inequality. Not the case here. So x is greater than or equal to -8/3. Let's see, 3 goes into 8 twice with 2 remaining. So any number greater than or equal to -2 2/3 if I look at the graph of that. So let's just double check. So I think this is the domain right here. In interval notation, I would start at -2 2/3. I'm going to call it -8/3. I can actually plug that number in. It just makes the inside 0, and the square root of 0 is 0. That's okay. So square bracket, because I can use it, and then go to the right forever, infinity. And infinity isn't a number, so it never can get a bracket. It's always a parenthesis. What's the graph of this thing look like? Let's just clear out that mess and zoom back to the home screen. And we want f of x equals the square root of 3x plus 8. And what we should find is right here, -2.6666, blah, blah, blah. They're rounding it to -2.667. That's my -2 2/3, my -8/3 that this function starts at and then heads to the right forever. So the graph just verified what I calculated. One more. Sine of x I have here, so you might remember that from a trigonometry class. And I plotted a few points just to remind us about that. Remember, the origins of the sine are the unit circle. So circle of radius 1 centered at the origin. 1, 1, -1, -1. And if I know an angle from the positive x-axis, let's call that theta, then this point right here, the x value of that point is the cosine of theta, and the y value of that point is the sine of theta. And so for any angle theta, I plug in the y value of the point on the unit circle is where the sine comes from. And if we graph the angle on this axis over here, so this is a very different view of the sine than the unit circle, versus the y value of that point, we get this wave there. So that's the origin. And I want to know what's the domain here. So domain is what x value can I plug into? And if you look at this on your calculator, you're going to see the wave just keeps waving, and it looks like it keeps going that way forever. But how do we really know it goes on forever? Think about the unit circle version for a sec. So if I draw a radius here, and if I rotate that around, every time I move it, I get a new point, right? And that y value of that point is what the sine is about, given the angle that I'm forming with the positive x-axis here. And if I go around, here's 180 degrees or pi radians. Over here would be 360 degrees. I just went around once, that's 2 pi. And I could go around twice, that would be 4 pi. I could go around 3 times, that would be 6 pi. I could go around again, I'm losing track, that would be 8 pi. And every time I make a trip around, I'm cycling through this same set of points in that wave right there. Right, so right here, I just completed a journey of 2 pi radians. Now that's a positive rotation as I go around, and that heads me this way because I can rotate around forever, around and around and around and around and around. So I'm going that way forever. And it turns out we can rotate the other way. So if I were to pick a radius starting here, oops, let's try a pen. Pick a radius starting here and rotate backwards, that gives me negative angles, and I can rotate negative angles forever and ever and ever, which means I can go that way forever. Point here, domain for this function is all real numbers. May not be obvious, but that's the case. In interval notation, that would be parentheses negative infinity, go to the left forever, and go to the right forever. So that's another way to state the domain. So domain and range, domain, what x values do you have to play with? What values of the independent variable are you allowed to plug in? Range, oh, I didn't do range of this sucker. If we think about the range, we can see on the graph here that we hit this max again and again and again, and that max is y equals 1. And we hit this min down here again and again and again, and that min is -1, which comes from the origins on the unit circle. The y value can go as high as 1. This is the unit circle. What does unit mean? Unit means 1. Radius equals 1. So the highest I can get for a y value on the circle is 1, and the lowest I can get on the unit circle is -1. So that's the range, max and min there. So range is not all real numbers, but it's any y value that's greater than or equal to -1 and less than or equal to +1. Interval notation, -1 to 1 for the y values. All right. Hope this review of domain and range was helpful. Do good math, stay in touch. Adios.